Okay, this is a complicated looking thing.
I got a bad feeling about this.
Me too. First of all, notice that these positions are changed. What I have highlighted now is the M, and this is the N, because the dy and the dx are switched from what we normally see. So first we need to see if it's exact. So finding the partial of this one with respect to y, well, that's going to be kind of easy. 2xy sinh of x plus 2y cosh of x. That's easy enough. And we also got to verify this was the same, but this one's a little bit more of a challenge. When we take the derivative of this, it's got to be with respect to x. Well, the derivative of either y with respect to x is 0, but this one will require the product rule. So we would have 2y cosh of x plus 2xy sinh of x. And so there we have it. That's exactly what we were expecting. So that indeed is enough to tell us that we do have, in fact, a exact equation. Good. Okay, now that we know that we have an exact equation, now we want to solve the darn thing. So, integrating this one with respect to y, I guess I'm doing a little opposite order from usual. Integrating e to the y is e to the y. Integrating this with respect to y, well, that's just constant. So, and the 2's will cancel because we get y squared over 2. So xy squared cosh of x plus some function g of x that we do not know. All right. Now, what about this f of xy equals xy squared sinh of x plus y squared cosh of x dx? That's this thing, and we want to integrate that with respect to x. This part is no problem, y squared sinh of x, right? That's there. This part is tricky, because in order to do this one, we're going to have to use integration by parts. Or I guess I could use integration by cheating, but I mean, if you let u equal x, dv equals sinh of x, you should get that to work out to be this right here. What I have highlighted right at this moment. So xy squared cosh of x minus y squared sinh of x, those two which cancel out. But I just wanted to show you that indeed that is what you get. This was with respect to x, so we should get what I hoped we would get. Y squared times x cosh x minus y squared times sinh of x, right? If you see that, I think you can see, I didn't mean to do that part there. Whoops, that was an accident. Yes, I believe you do see that I get that. No, you don't see that I get that. So I got to do some undos here. Hang on a second. Undo this. Undo this. Undo this. Undo this. Undo this. Oh no, undo this. Undo this. I can't undo anymore. I want to undo what I had here, but what I had here was that integral. Actually, let me go ahead. I'll just copy it from here. This is what I had. Slightly different form from that, but that is what I had originally. So I'll pop that in there. And maybe you can see that this was y squared sinh of x, which is going to cancel out with this one with this negative sign. So x y squared cosh of x. And so that's the part that's common to both. So it's going to be that plus some function h of y, g of x would be 0, and h of y is the e to the y that we didn't have. So our solution is just x y squared cosh of x plus e to the y equals c. That is the, of course, I don't even want to try to do it explicitly, but that's the implicit solution to this differential equation. Now, good question would be, well, can you check that? And how would you check this? We'll find the total differential of this equation. So partial derivative with respect to x needs a product rule here, and then this is 0, and then this is 0 also. So then the partial derivative of this with respect to y, 2yx cosh x, and e to the y, 0 there. and see if they don't fit into our total differential, which was up here. Remember, these are reversed. Whew. I think we licked that one. Okay.